Hey guys, part A of the last problem here on the AB 2017 FRQ, and in part A we're asked to find the slope of the line tangent to the graph of f at x equals pi. So what they're asking us for really is f prime of pi, right? Okay, easy enough. Let's first find f prime. Since f is right here, f prime of x will have to equal the following, right? Which is negative sine of 2x, and then by chain rule times 2, and then plus e to the sine x, and then by chain rule times cos x. Now we can clean this up a little bit, right? Minus 2 sine 2x, and then plus cos x times e to the sine x. Yeah? Okay, cool. So f prime of pi then is going to have to equal negative 2 times sine of 2 pi, and then plus cosine of pi times e to the sine of pi, right? Okay, cool. Now, I don't know how you evaluate sine of 2 pi and cosine of pi and all that good stuff, but for me, like, I just think back to the graph of sine and cosine, and so it's easy to know that sine of 2 pi is 0, so negative 2 times 0 is going to be 0, and then cosine of pi is negative 1. So we have negative 1 times e to the sine of pi is 0, so e to the 0, and so this is negative 1 times 1, so just negative 1. That is f prime of pi is negative 1. Keep that in mind as we do part B. Yeah? Okay, cool. So that's it for part A. Our answer is negative 1, and let's move on to part B. And so part B, where is part B? How about here? Yeah? Okay, so part B says to define the function k of x to be h of f of x, and then we need to find k prime of pi. So this is just an exercise on using the chain rule, right? Like, so from the way that k is defined by chain rule, we know that k prime of x will have to equal h prime of f of x. Let me redo that f. H prime of f of x, and then times f prime of x by chain rule, right? Okay, so that means k prime of pi is going to have to equal, h prime of f of pi, and then by chain rule times f prime of pi. But remember, in part A we said f prime of pi is negative 1. So I could just do this, write a negative right there, and we're good, yeah? Okay, cool. There we are. So this is what we have to find. Well, priority number 1 then is f of pi right here, right? Okay, so to take care of that, let's come over here and write f of pi, and since f is right here, that just means that we find out what cosine of 2 times pi, therefore cosine of 2 pi, plus e to the sine of pi will be. Well, cosine of 2 pi is equal to 1, and then we'll have plus e to the sine of pi 0, so we'll have plus e to the 0. The e to the 0 is 1, so we have 1 plus 1, or 2. That's equal to f of pi. That means that I can come in here and get rid of f of pi and replace it with the number 2, right? Okay, cool. There we are. And let me do it in blue. All right? Okay, cool. So there we are. So now we need to find h prime of 2 and then take the negative of h prime of 2, right? Well, notice that the only information we're given about h is this graph here. And h prime of 2 concerns the slope of h at x equals 2. Since h is made up of a bunch of segments, we concern the slope of this segment here for finding h prime of 2. And the slope of this segment going from x equals 0 to x equals 3 is negative a third. That is, h prime of 2 is negative a third. So we have negative from this negative sign, and then since h prime of 2 is negative a third, we have negative a third, and therefore positive a third, and that's our final answer here. Yeah? Okay, cool. Part C here, and in this part we have a function m of x defined to be the product of this guy and this guy, and then we're asked to find m prime of 2. So this question is just an exercise on product rule, and again the product is between g of negative 2x and h of x, so we just need to execute the product rule. But as we do the product rule, we'll have to find the derivative of this guy, which will in turn require that we keep in mind the chain rule. But yeah, m prime of x can be found using the product rule, and again the product is between this guy and this guy, so we do the derivative of this times that, and then plus this times the derivative of that, right? Okay, so that'll mean that we write g prime of negative 2x times negative 2 by chain rule, so times negative 2, and then times h of x, and so now we've written the derivative of this times that, and then we need to write plus this times the derivative of that, and we'll be done with the product rule, right? So times g of negative 2x, or plus g of negative 2x times h prime of x, right? Okay, there it is. And m prime of 2 then is going to have to equal g prime of negative 2 times 2 is negative 4. So g prime of negative 4 times negative 2, and then times h of 2, right? We're plugging in 2 everywhere we see an x in this expression. So plus g of negative 4 times h prime of 2. Okay, cool. Now, some of these things we're going to be able to find from the table, some other ones from this graph here, right? Okay, so g prime of negative 4. We go to g prime, and we go to negative 4, and we see that it's negative 1. So we get negative 1 from this, and then times negative 2. That's just going to be 2, right? So we have 2 so far. And then h of 2 is going to be evaluating the function h at x equals 2. Now, if you want to be very careful, you can find the equation of this line here, and then in that equation plug in x equals 2. But I can see very quickly that when x equals 2, the corresponding y value is negative 2/3. So I know that h of 2 is negative 2/3. So I have 2 from that, right? Negative 1 times 2. And then h of 2 just now we found is negative 2/3. So I'll have 2 times negative 2/3. And then plus g of negative 4 will be like g, and then go to negative 4 and read off, and that's 5. So we have 5. And h prime of 2. H prime of 2 from our work in part B is about the slope of that segment right there. And we said that it was negative 1/3. So negative 1/3, right? Okay, there we are. So now this is going to turn out to be negative 4/3, and then minus 5/3, which is negative 9/3, also known as negative 3. So that's my final answer. Yeah? Okay, so that's m prime of 2, and that's it for this part and this video. Well, not this video, sorry. We have one more part and we'll be done. All right, and that part is part D. So what does part D say? Let's see. Part D, the final problem of this FRQ is going to say this, which is what? Is there a number C in the closed interval blah blah blah? And I say blah 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 because as soon as you read it, it's screaming MVT, mean value theorem, or maybe MVP for me, yeah? No, just kidding. Anyway, what does the mean value theorem say? It says that if you have a function g that is continuous on a closed interval AB and differentiable on the open interval AB, then there must be a c in the open interval AB so that g prime of c will equal g of b minus g of a divided by b minus a. Now they already told us that g is differentiable on this closed interval. And differentiability automatically implies continuity. So that means that G is continuous on this closed interval and surely differentiable. And therefore, by the mean value theorem, it's guaranteed a C that will equal a C inside of the open interval -5 comma -3, so that G prime of C will equal this. And so all we have left to do is see if this thing here is going to give us a -4, because otherwise the function G we're given fulfills the hypothesis of the mean value theorem. So it's guaranteed such a C. But this has got to be -4. And of course, A and B are -5 and -3 respectively. So we see if G prime of C will equal, let's see, G of -5 minus, or no, B is 3. So G of -3 minus G of -5 divided by -3 B minus A, so minus a -5. That's -3 plus 5, so that's 2 in the denominator. Now, the numerator here, well, what is that? G of -3 will be like, go to G and go to -3 and read off. That's 2. And then G of -5 is 10. So in the numerator, we have 2 minus 10. And then the denominator is still 2. That says -8 over 2. And that surely is -4. So the answer is yes. The mean value theorem guarantees us that since G is continuous on the closed interval -5 to -3 and differentiable on the open interval -5 comma -3, that there must be a C inside of the interval -5 comma -3 on the open interval -5 comma -3, so that G prime of C is equal to -4. Yeah, you don't have to write all that, but I basically summarized all of it for you. All right, cool. I hope you enjoyed this and keep watching. Take care.